Good afternoon, everyone. A warm welcome to Hexagon's Leica Intelligent Grading Solutions presentation. My name is Ravi Shankar, and I'm taking care of machine control construction division in India. So today's our topic is the intelligent grading solutions with Leica. First of all, let us understand what is grading. A good roads can be built only if you do the proper compaction during construction. So, if you are not doing proper compaction, you will end up with bad roads, which results to potholes, rutting, and other things. That is the failure of the roads. So, for achieving the compaction, right compaction, we need to spread the layers, means the material in layers evenly. So this slide shows this dotted lines is the actual layer thickness where it has to be spreaded. So the road is always built in layers because again for the same reason you cannot compact more than 200 to 300 thickness. So how to spread the material evenly? We have two machines. One is the dozer, this one, and the other one is the grader. These two machines will spread the material evenly during construction. If you are not spreading the material evenly, what happens? So if you have a over thickness, there we will end up with under compaction. And if you have lesser thickness, you will end up with over compaction, which results the cracking of material or crushing of material. A dozer is a small equipment. Of course, it also has different sizes. What I mean to say is it's not small, it's a slow moving equipment. Means operator has ample time to move the levers to control it hydraulically. Whereas in case of motor grader, this is motor grader, it is a fast moving equipment and absolutely operator has a very less time to operate the hydraulics to bring the blade to the finished grade levels. So that is the basic difference between these two machines. A dozer can push a large quantity of material, whereas when it is coming to the motor grader, it has its own limitations, but it can move fast. Let us understand what is machine control. Machine control is controlling the hydraulics of construction machinery with a sonic sensor or a laser leveler or a total station or a GNSS. GNSS stands for Global Navigation Satellite System. In general, people call it as a GPS, Global Positioning System. So this controlling either can happen manually. I call the system as guidance. Means in front of the operator, there is a display which makes him to understand what is the finished grade level and to be attained and what is the position of the blade. The next variant is it can also happen automatically. Means the system what we are installing, it automatically drives the hydraulics and ensures that the blade is moving to the actual finished grade level. How it does is it needs a 3D design. The difference between a design and a drawing is 3D design has northing, easting, and RL at any point of the drawing, whereas drawing is only a linear measurements longitudinally or in the transverse direction. So we need a 3D design to give input to the machine. Then only machine will understand at what level the machine has to perform the finished grade level. There is a general format called land XML files. So this output comes with any CAD-based software. Any land XML file, Leica machine control system can understand that. You don't require any separate software to convert these models so that the machine can understand. Like a machine control system, it can directly understand the land XML files, it can read and it can perform. And land XML files are a very simple files from any CAD-based software. So once we are giving the input of the 3D design, so what happens? The work will happen within the tolerance specified because we are automating the machine and we are directly putting the design what the consultant or the client has given. Absolutely, there is no human intervention in it to make mistakes. And definitely, when you are doing everything automatically, you will be avoiding the reverse. When you have a manual intervention, there could be a chance of doing a mistake, and there could be a situation where you need to do the rework. So once the work is performed, you can measure the one what you have done. You can record the as builds, whatever the machine finished grade levels the machine has performed, and at the same time, you can monitor the operator screen real time remotely. If at the worksite place, for example, for a road construction, if there is a GSM signal, means cell phone signal, we will be inserting a SIM card in our hardware where it enables anybody all over the world who is connected with internet. He can send the design, receive the as builds. At the same time, he can monitor the real time work what the operator is doing because he'll be able to see the operator screen. So when we need to use the guidance method, that is manually, and when we should use the automatic one. As I explained you, this dozer, it gives you time because it's a slow moving equipment. It gives the time to the operator. Here we will be opting the guidance method. The guidance method is the display will enable the operator to have an idea whether he has to lift the blade or he has to lower the blade. And he has ample time to respond and move the blade to achieve the finished grade level. Whereas in case of motor grader, you need to go with the automatic one. The system comes with a proportional valve fitted parallelly to the machine hydraulics. Everywhere we'll be having a T-joint at the pressure point, at the load sensing point, at the tank return point, and also at the hydraulic jacks in and out on both sides. So in this case, this my system, the Leica system, what we are installing, it reads the 3D design, it understands where what is the northing, easting, and RL reading, and it gets the signals from the satellites. If you see these satellite receivers, I mean the GNS receivers are exactly mounted on the blade. So it receives signals from the satellites and it calculates northing, easting, and RL with RTK correction. So this RTK correction can be either with a radio or with again a GSM. So then it compares what is the position of the blade right now and what is the actual design which has to be, the blade has to be done. The difference, either it will be display in the form of a guidance method or it gives commands to the proportional valve to move the blade automatically. So altogether, this is called machine control. So what are the advantages of using a machine control? Absolutely, there's a big advantage. The first advantage is you will be avoiding the stakeouts completely. In a conventional method, for every 5 meters or 10 meters, both these sides, first of all, you have to establish the center line. Then you need to measure the offsets, means you need to define the width of the road to be graded. And third, for every 10 meters, you need to drive the pegs. And operator will be doing with his experience. And in front of him, people will be measuring it with the line dori, and they will be giving directions to the operator to raise the blade upward or to move the material downward. So all these things, we can stop it. This we call it as a stakeout. So only you will be needing 25% of the time. 75% of the time, there is a reduction for this job site preparation and stakeouts, because there is no need to mark the center line, no need to mark the edge lines, and no need to drive the pegs. But at every 10 kilometer, 10 sorry, at every 10 meters interval, then definitely it will reduce the number of passes for grading. So once it is reducing the number of passes, it is saving 31% man hours, includes everybody, that operator, and machine hours, 34%, project hours, 46%, and absolutely there is a saving in fuel consumption, as the work is done with a reduced number of passes, and also the wear and tear of the machine. So in total, a price of 30% of the machine cost will increase nearly 50 to 60% of the productivity. So these are the advantages of having a machine control, and you will be getting the payback within 6 to 12 months, depending upon the project size. So what are the variants we do have and where we will be using them? See, we have a variant called 1D, 2D, 3D. Let us understand what is 1D, 2D, and 3D. 1D is an application where it addresses only the height part in the longitudinal direction or in the transverse direction. Means it controls only the height of the grading. The application you can see here, you'll find most of the laser land levelers which are used for agriculture purpose. And the same you can also use it on the dozer as well. So when you have a large area where some factories are coming up, or where we have a very big area where you need to do the site grading at the same level, then this 1D system is viable to use for that application. Then coming to the next one, 2D. So for 1D, you don't require any design. It is just telling it at what level it has to do the leveling part, and the machine control continues at the same level. 2D is also the same. It addresses with both height and slope. Means, for example, if you take the example of a road, there will be a slope in the longitudinal direction and also a cross slope in the transverse direction. So this 2D addresses the height in both the directions, means the height in the longitudinal direction and also the cross slope for the roads. Normally the slope is somewhere around 2%. So if you have flat terrains, whether they are truly horizontal or sloping upward or sloping downward, we can go for this 2D solution. But if we have a transition horizontally and also vertically, means the horizontal transition is your super elevation, and vertical transition everywhere you find before and after a culvert. So the second application is the 2D. In India, for using this 2D technology on roads is a little bit difficult. If you consider 200 meters as a single stretch, it will be difficult to get such flat surface, either horizontal or sloping upward or sloping downward, more than 20 to 25% of the whole project. So ideally, for the road construction work, we have to go for 3D. Then what is 3D? 3D, it addresses everything, but you need to have a design. How it is able to address everything is, as it has a reference positionally northing and easting and height with reference to RL, it can address any complex designs, whether you have a transitions vertically or horizontally, what you call the so-called super elevations. And in 3D also, we have two systems, as I earlier told you. One is the indicate and the other one is the control. Indicate just is simply displays what movement has to be done. Control, it takes the hydraulics into the control and it starts moving the blade. But at any point of the time, operator can override this automation by just pulling the lever to lift the blade up or down. So, as I told you, these are the Dozer variants, and these are the Leica brand names. Leica Power Blade, we call it as 1D system, and we have a Leica Icon Grade 2 systems also, and we also have Leica Icon Grade 3D system, which we call it as IGG3. When it is coming to the Dozer application, for 2D, we have different combinations. You can see the grader, it has a blade horizontally like this, and it can be controlled on the left hand side, on the right hand side separately with a lever. We have a dual sonic setup, means there is a sensor called sonic sensor which can be fitted on either side of the blade, but it needs to have a already built up surface or a string line to perform. The second model is we have a single laser receiver, and it comes with a slope sensor, and you need a laser leveler so that it retrieves the datum from the laser leveler, and it takes care of both sides with the help of the slope sensor and also a laser receiver at one side of the blade. The other one is we can have a combination of these two. One is the sonic sensor, one side, and a laser receiver on the other side. And the other fourth one, what we have is a dual laser receiver, which is having two lasers on both sides of the blade without a slope sensor. So these are the different variants in grader for today. So let us jump into this gradient variant 3D. All the variants in my earlier slide, whatever I've shown you is informative and for specific applications. And today, our focus is more on this 3D variant, particularly this technology already started emerging in India. So this is the 3D variant what Leica has. It comes with two GNSS receivers. These are the two antennas. And the actual GNSS receiver we do have inside the cabin. And this is a patented one. It has an ability to collect two data from two different antennas at the same time. And this is the control panel where operator has an where it displays and shows the operator how the work is progressing. And this also sends the signal to the hydraulics. And we also have the tilt sensor, and also in our configuration, we give this tilt sensor along with the package, even though the machine has the pitch and roll moments, and also a tilt sensor for calibration of the machine. This rotation sensor is optional. If you want to use it with a total station, then this rotation sensor you require, or if you want to use it as a single GNSS antenna system, then also you need. We are more keen and recommend the customers to go for dual GNSS with the two GNSS receivers, where you can avoid this rotation sensor, which gives more accurate results. And we also have a junction box. So this is the configuration of Leica 3D. And one important point regarding the design. Normally, these are the formats: AutoCAD WDG, AutoCAD DXF, and Land XML, MOS, RAB, SPOL. So all these formats, we have a software which is an optional. That software has an ability to convert any given format data into Land XML, where my machine understands and it starts working. And a part of this, it can also has one more capability. These are the models, what my machine can understand. It can understand a string line model, it can understand a terrain model, it can understand a tin model. And normally in the work sites, what you find is we have the northern, eastern, and RL at the center line with the chain edges, and they give the offsets of some distance with that RL at that particular point. So if you have the data like this, the optional software, what I'm calling Icon Office, It has an ability to create a design. But as I told you, if the consultant or the client can give us directly the land XML file, you don't need any software from anybody, as the machine has an ability to run on that particular format. Then the grade control. What is grade control? It is an automated system for earthwork machinery. It detects the difference between the design and the finished grade, the position of the blade, and it corrects, means by operating it, by giving a display to the operator, or hydraulically. How it does is, it takes various inputs from various sensors, as I showed you. The sensors could be the laser, the sonic, the total station, or a GNSS, and also from various sensors like tilt sensor, slope sensors. So with this, it processes with respect to the design, and it gives a display, an output by the way of a display, or controlling the hydraulics. Let me show you a small video on this.
Motor graders are a complex finishing tool on a road construction site. To skillfully operate a motor grader freehand without the use of a grade control system takes years of on-the-job training. With the Leica Icon IgG4 machine control system, precise motor grader operation is easy and efficient. Even less experienced operators achieve accurate results in a short time. The Leica Icon IgG4 dual GNSS machine control solution for motor graders gives you precise control of the blade, regardless of its position or articulation of the machine, allowing you to make full use of your motor grader's functions. Crab walk your motor grader to properly handle material windrows and use automatic hydraulic control in applications previously impossible, such as creating ditches or grading side slopes. This new Icon IgG4 solution increases your productivity and accuracy and gives you the opportunity to accomplish more site tasks than ever before. With the Icon IgG4, Leica Geosystems once more prove their leading position in construction positioning and machine control technology. Get the best out of your motor grader and push it to its limits. Leica Icon IgG4 Dual GNSS machine control.
Yeah, there are 2 points to be discussed after seeing this slide. One is, you are seeing IgG4. In this variant, we are trying to promote IgG3 in India. The IgG4 is, you can also have a hydraulic control on the side shift of the blade. So it takes some time for the operator to understand this high-end one. So initially, we are trying to go with IgG3, only moving the blade up and down instead of controlling the side shift also. The second point is, you will be needing only an operator who can just operate without any best skills. You need to know how to operate the grader, and he will be only controlling the steering. You don't require a highly skilled or very experienced operator. Absolutely no, because the other functionalities like a system will be taking care. So now in India, it is becoming difficult to get skilled operators for executing this kind of works. So that gap can be filled with this like a IgG3. So these are the run screens in front of the operator. I'm repeatedly telling you it guides the operator. So how it guides? You see, the green line is the design, actually where the road has to be formed, means it is a finished grade level. So operator will be seeing the blade like this, and he has to ensure the blade is moving exactly on this green line if he is doing it manually. On the two sides, you can see once it is 0, when it is moving exactly on the finished grade level, it displays you 0 in green. Once it deviates from 0, and you can give the tolerances like 5 mm, 10 mm, or 1 centi. If that goes beyond that, the reading will continue, but it will show you in red color. And this is the one more other view where the operator can see only the blade position. The other run screens like this is absolutely just the reading, what he gets on the left hand side, on the right hand side, and the deviation on the screen. The other one is like this. He can see the whole machine and the whole area he has to do, and also the design part. So this is the one more run screen. If he is doing addressing a flat terrain, a big area, he is doing the grading, then he will be preferring this kind of view. Coming to the Leica product. So why people has to look forward to buy Leica grading system? We have some special features in our system. The first one is the display. This display doesn't require any harness to switch on. Harness is nothing but the wired connection. And it comes with a speaker. This is fully touchscreen. It also has the hard keys. And why you need a speaker is we can create avoidance zones. If we say that the machine, if it is going beyond this line, just give an alarm. It starts beeping. And it has arrow keys. It has a USB port to put in the data or take the as builds. This is a completely touchscreen one where we have not seen with any competition. And this goes and sits with this docking station. This docking station is the third generation one what we have. All the hardwares, your wall module, your power module, your CAN communications, the serial communication, the SIM card bay for GSM signals, the Ethernet, everything comes in this compacted docking station. That display goes and sits in this docking station, and this video will explain you clearly what I'm trying to.
Introducing the new hardware platform from Leica Geosystems Machine Control. The new hardware supports all 3D machine solutions from Leica Geosystems. It can be used interchangeably between any heavy construction machine. The Leica MCP80 panel is built with a customer-centered design with 8-inch full-color touchscreen, backlit hardware buttons, and arrow keypad. It is protected from extreme temperatures, dust, and water, making it truly resilient for the heavy construction industry. Designed for inside cab or external operation. The docking station powers the panel, making it completely cable-free. Machine-specific settings are stored in the cradle, enabling the operator to use the panel on other machines. Robust connector support of all manufacturers. GSM antenna and SIM card bay support the data handling platform Leica ConX. The rugged locking mechanism secures the panel to the docking station. One docking station. One panel. One carrier of all solutions.
The same display can be used for different applications. Means you will be saving a hardware of somewhere around 3 lakhs. If you want to use the same display for multiple, you can use it on the dozer, you can use it on the motor grader, wheel loader, driller. These are the applications what we have for the complete machine control construction profile. Along with this, we also give a base station. As I told you, you need a base station for RTK corrections. The machine receivers acts as a rover basically, and it needs a correction for the accuracy part. So we give a base station called ICG60. So our configuration includes an external battery like this, and there is also a device to measure the height of this tripod. Means you just pull it and note the reading and just feed it. You don't absolutely need a controller for operating this base station, as this comes with a small display and also keys to operate. So these are the advantages of having ICG60. You don't need a controller, and we are giving a height measurement device along with this. We are also giving an optical plummet. We are also giving an external battery to work for the whole day, and it comes with an integrated radio and also the high-speed 4G modem. It also works with GSM corrections with a SIM card, which is free for lifetime. And we are doing this end-trip corrections without any cost. So these are the advantages of Leica ICG60 for using it as a base station. This is the rover what we give. It comes with a big controller like this. So what happens is it shows at what level of freeze grade leveling has happened after the work. This is just only for cross-checking. This again comes with ICG60 with a big controller like this. And the design you can also feed in this, and it also gives the differences of actually what the drawing is, what the design is telling, and what exactly which has happened on the ground. So we have given a trial in India, and this is the 1 mm accuracy what we achieved with the Leica IgG3 system on motor grader. So coming to the machine components, as I told you, when machine has vibrations, the basic physics says you need to use a lightweight components on that. That's the reason we divided our GNSS receiver. This is the one. This goes into the cabin with two. These are weighing somewhere around a kg on either side. These are only the antennas part, which we are putting directly on the blade. Whereas if you see the others, they come a very heavy one mounted on both sides of the blade. It's a combination of everything inside. That's the reason why it has an increased weight. And this can be used, our system, we call it as ICG82. This can be used as a base station at any point of time. Not only that, if you are using it for some heading purpose, heading means it gives the direction for any machine. For example, if you are using it for a barge, floating barge in a sea or a river, and you have some third-party systems with that particular barge to measure the depth or something like that. This gives you the heading. This also gives you the anemia output. Anemia output is a feature where you can connect it to the third-party devices for giving the readings of northing, easting, and RL from both these antennas. So that is also possible with this Leica ICG82 what we are giving. And the components are very simple. Hardware, everything is coming into this. We don't require any specific hardware for putting the SIM card, for putting the radio, or for putting the power module or wall module. Nothing. Everything comes with this compacted docking station, as we are trying to promote the third generation one. Hydraulics also, normally people use a manifold, upon that a solenoid valve. Whereas Leica uses Danfoss proportional valve, which is a combined one of the manifold and also the solenoid. And the other ones, it is directly fitted on either side near to the cylinders, hydraulic cylinders, whereas in our case, we are fitting it under the cabin. So all the connections goes from this single Danfoss proportional valve to the load sensing, the pressure port, the return port, and also for moving the jacks up and down on both the sides. So this is one more advantage and one more superiority in case of hydraulics, what Leica is using. So that is the end of the presentation, and I request if you have any questions on this particular subject. Thank you very much for attending this presentation. Vishwajit, are you there?
Yeah, I'm here.
Yeah. Have you received any questions in the chat box?
No, I'm looking for the same.
Yeah,
Even I
yeah.
am waiting for anyone.
Yeah, yeah. So absolutely, there are no questions. I hope it is well understood with the participants.
No, Prithvi has dropped a question. His question
Yeah.
is, what is the cost of the system to install in a radar?
In the what is application in the radar?
Yeah, what is the cost of the system to install in the radar?
Grader. Okay. So we are trying to promote this somewhere around 40 to 45 lakhs. The
Okay.
whole, yeah, it comes with the base station, it comes with the rover, and it also comes with the machine components. Whole set I'm talking about, whatever I have shown you.
Thanks, Ravi. Hope Prithvi, your question has been answered. If anyone is having another questions, please drop them in your chat box. Okay. Thank you, everyone. This concludes today's webinar. Please join me in thanking Ravi for this informative session. Please note his number in case you need any further information. It's visible on the screen along with his email ID. We'll also be sharing the recording of this session should you wish to listen back to the webinar. We appreciate your time and hope you have found this webinar to be a valuable experience. Thank you, everyone. Thank you, Ravi, for the session.
Thank you, everybody. Thank you very much.